Heck yeah, man. That's giving off some shock right there. Very cool. You get some polarity with the plasma when you throw a magnet on there. You get like a white end and then a darker purple end. At least when I put the crystal, the chevron, inside the magnet, it was like it went off the top to the chevron and went down on the bottom to the magnet, and it was really white down on the bottom and it was purple on the top. Don't know if that means anything, but you know, since it doesn't do it at any other time than when there's a magnet involved, I'd say that that's polarity. All right. So we're going to check this out. This is all 6 magnets facing the same direction. So these coils were wrapped clockwise, so they're all South Pole coils. Something like that. So you put south facing in towards the magnets. It's going to be overkill though with the 6 magnets. I always want to keep it like before it gets to a dangerous speed. Now I have 2 builds. Now I have the Utron, like full size. And then I got, but this, it's already broken. I mean, it weighed too much. It's nice and solid though. But the place where the bearings were supposed to go, I can only put 1 bearing in there right now. And then there's this addition that I gotta glue on there. Like I gotta put it in, I gotta put the bearing in, put it on, put the bearing in this one, then put it on the shaft to line it up. And then I gotta glue this part down. So it sucks. It was an engineering flaw from the start. Let me show you what it was. It was this right here. This is the piece that broke off. And there's like no way that was going to hold a bearing on both sides. It's like not even circular. And I don't even know. My printer, I had it on silent the whole time. So maybe that was the problem. It was going too slow. I don't know. I don't know. But this works. I'm glad this one works. This one is a lot lighter too. So we're working with 180s. So the experiments I want to try, I'm going to try on phase, off phase. So I want to try like a 120. That'll work with the 90-degree angle in the middle. And that'll be 1 on, 1 off all the time. But I think it should still be pretty tight, pretty strong. Like if you've seen, we'll do this one more time. This is 6 magnets facing southward. We're getting there. All right. So you see that's overkill. We don't need to go that fast. It's like not controllable at that speed without a controller, which we're not going to do right now. We're not going to do that right now. We will eventually do it, I'm pretty sure. Like an Arduino, and it'll take the place of one of these breadboards, basically. All right, so what we want to do is we want to go from the 60 degrees to a 120. And I'll do that real quick. All right, so this is 120 degrees. All magnets are facing inward, south, inward, south, outward. See, there's only one chirp though. That's right. That sounds absolutely perfect. Woo! That's smooth. That's really smooth. Almost felt like letting that one go, but we got a couple more experiments to do. All right, so that's the one hit at 120 for the. There's only one coil active on the rotor. I thought I should mention that. And then the other coil is being driven by the pickup system. So the faster the one drive goes, the better off the second drive will be. And there's no like real cap to how much you can put into the second drive. As a matter of fact, you could end up putting in more based on how fast it goes, because it's going to store it in the cap bank right here. If it's not spending as much as it's making. And I don't know how else to put it than that. I know there's a mathematical way that will make everybody happy, that I could say that, but that's basically what's going on. When the lights start lighting up, actually I haven't seen the lights light up. So currently that's not happening, but I've seen it happen on this side. I've run another motor and not used the amount that I was creating. I wasn't creating it. I was just like, well, I don't know how to say it. You know, just call me ignorant, you know, but you do know what I'm trying to say, right? Now, here's the 180. Now, this means that both coils are going to be in play. And this one should, I don't know if it's going to go faster than the last one. That's pretty smooth. All right, I totally forgot. I'm lost track, but I'm going to go over to the phone in just a second here. This is 2 on 2. This is awesome. That was going to sync up, I'm pretty sure, at a pretty fast pace. Granted, that was awesome. So I think the 180 with the 2 south facing inward is going to be gold. Hello, hello. Oh man. It's all right. And then now we're gonna do we're gonna flip this one around. So we're gonna do a north-south on the 180. There we go. That's a nice tight fit. That's awesome. All right, we're gonna turn this on. So I wonder what the reaction to the north facing inward is actually doing. It's not chirping. That's one chirp. So it's not chirping. But it's doing something. It's not like it isn't there. I'll show you what it isn't there, what that looks like in just a second. Oh, that's pretty solid. That might even be syncing up. Looks like the bottom's moving a little slow though. Oh no, that's going way too fast on the top. That's awesome though. I could walk away from that. I could literally like go do the laundry and not even worry about it. Not even worry about it getting hot, nothing. I wouldn't even worry about it. Oh, that's so cool. All right, let's find the one that's south, that's north. All right. All right, so now we only got one magnet in the stator. One coil on the rotor, and one magnet in the stator. That's pretty cool. And the second drive, I don't necessarily consider that being on, really. I mean, it doesn't work unless the first drive, the one drive, is on. So, you know, I mean, it does work, but it needs the one drive to make it work. Oh wow, dude, that's awesome. It's mesmerizing. But the weight is kind of making everything wobble a little bit. So I'm going to put the other magnet back in there. We're going to do it like that. Here, let's see if we can get this cat bank to light up. Now see that looked like a blown transistor right there. But we did have energy in the cat bank. It's just all right. Yep, that's blown. And that's all I got for right now. I got a bunch of blown ones over here. I got a few weaker ones to try those out. They don't blow that often, but I've been playing with these for like the last week and a half. So, which one? I know what to do, I think. We gotta get some more MJLs, I guess. Yes. All right, let's see. Ooh, just kind of cascading down the cascade of transistor mayhem. Oh, that's so neat. So, I mean, I went from 6 magnets to 3 and 3, which is 3 south and 3 north. We can do that again. I haven't done that yet. That might be interesting. Because this is how you do it for free. This is how you do it with the knowledge that you have already. You adjust your magnetism. It's not, just look at these magnets. Look them up. Okay? And I do the best I can. Really, I do. They're neodymium M52 40 by 20 square. Boom. All right, one more to go. Here it is. So we'll turn these on. And oh no. It's blown. Oh. Oh, you gotta be joking. All right. That's unfortunate. The last time I turned it on, one of the jumper wires, and that's why I make my own wires most of the time. It was just easier to do with the jumper wire because they're flexible, but it popped out like a little bit more than halfway. Yeah, shorted everything out. So when I plugged it back in, you saw it had that much stronger reaction of it being totally shorted out. That sucks. Mm. Oh, yeah, that's not a good one. Let me get my bag. Let me get my bag. All right. We'll just consider those duds. I'll get my bag. Got 2 left. Voila. I just, thought I'd come on and show you where I'm at. Wow, man. Yeah, we'll call it after this. I'm kind of losing my mind. It's all right. It's just everything looks. Yeah, that's not good. All right, so maybe they're trying to force me into doing something different. Just all the suggestions that I've gotten are kind of working on, this part instead of this part. But I think working on this part is going to be a lot better. Going to give better results. Because as soon as you get it to sync up and you get the bottom part to move as fast as the center part, and there's a top part to this too, so as soon as you get the top and the bottom to sync with the middle, then you can get some math, some concrete math that you can put into an Arduino, and then you can control how fast that happens. Then you got control. As soon as you get it to sync, you got to get it to sync first. That's the weird part. When it's a counter rotator, you have to find that equilibrium before you do the math, because you're not going to be able to do the math without it. As far as I know. I mean, it's out there, I guess, but it's really difficult to find. It's just get it to sync up, and it's really easy then. At least in my mind, it would be a lot easier than trying to force it. Maybe not as fun, but it's going to be a lot easier. All right. I want to show you something real quick first before I go. And that's what the other stator looks like. On the pole. Oh yeah. Well, it rides a lot lower, so the rotor sits a lot lower as well. There's a lot lower center of gravity. Everything, it shakes a lot less. Everything is less vibrational. But I gotta jerry rig something so I can get two bearings in it enough to keep it steady. Like this one, I lodged them both in the nose. So they're real close together down here. This thing works so much better when it's maglev, like so much better. Just enough to lift so that your bearing isn't like laying on anything. I mean, the pole can touch, that's no big deal. But everything else isn't touching, and that's huge. Freaking huge. I mean, if you want to get all off the pole and everything, that's great. You can either jerry rig something, or you can, you know, pay big bucks to get it done professionally, but it's out there. Yeah, like get it off the pole, and then it's just floating there, right? That's the objective, right? Does that ever really happen? I don't think so. I mean, if there's no pull to begin with, then I can see there not being a pull. But I mean, if there's always been a pull, you're going to lean on that pull sooner or later. I mean, you got the air bearings, and those keep going as long as you're going, I guess. Then you got that air pocket there. That's cool. But how much does that cost? And anything you're buying at the store is either going to be bent. I'm sorry, it's going to be bent or it's going to be warped. There's very little at the store. Like all this, these pieces of plywood are as big as they came that size, and they were like $12 a piece. So it's not a small deal. It's really not. It's wow. I don't know, man. I've lived without for a long time, and then tried to, get involved, and you really can't unless you're willing to, have some dibs or, double down. You gotta, and I've done thousands upon thousands of my own money into this crap. I've got like 3D printers. I got up the wazoo ferrite, ceramics, and neodymium magnets, just kind of all over the place. I got cubes, I got squares, I got cylinders that are based on the squares. I got N54s. At least that's what they call them. I don't know. I do my part. I have an Arduino. It's stuffed away in a pad. I'm not exactly sure where it is, but yeah, I got it. It's one of the super packs. It's got all its stuff too. But I have no idea how to use it. No idea. And then, I mean, it's like I don't really have that much of an idea about this stuff either. I'm good at certain things, and apparently they have no use. But I don't give a freaking, I don't care that everybody thinks that, there's no use and it's not practical and all this other crap. I mean, and then seriously, if you're coming in with a bid, or you better come in with that first, because I'm really like on pins and needles. All right. Well, we're not going to turn that on. Thanks for hanging out. Hell yeah. Peace out. Have a wonderful night. I'll catch you on the flip. I'll have more transistors and everything else. But yeah, and I gotta put it back together, I guess. We'll see what's wrong with it. It just popped 4 transistors, so I'm something's not right. I just charged the battery. There might be something wrong there. It's like how I put it back together. But then, yeah, the jumper wire popped out. I just remembered that. And I put it back in. All right, so when I put a new one in there, it should be good. All right, peace.